series with a resistor, the voltage source is value किती येईल? एका कॉम्प्लेक्स इलेक्ट्रिक सर्किट मी घेतलं, जे 2 पॉइंट्स ऑफ इंटरेस्ट आहेत तर मी ओपन सर्किट व्होल्टेज मोजलं आणि तिथं शॉर्ट सर्किट करंट मोजला. तर 2 इलेक्ट्रिक पॉइंट मध्ये मला VSC ओपन सर्किट व्होल्टेज आणि ISC शॉर्ट सर्किट करंट मिळत असेल तर ते इलेक्ट्रिक सर्किट हे दिलेलं जगातलं प्रत्येक इलेक्ट्रिक सर्किट ज्यामध्ये मल्टिपल व्होल्टेज सोर्स आणि मल्टिपल रेजिस्टन्स आहेत ते एक व्होल्टेज सोर्स आणि सिरीज मध्ये एक रेजिस्टन्स असंच आहे असं अज्यूम करता येतं. जगातलं कुठलंही कॉम्प्लेक्स इलेक्ट्रिक सर्किट की ज्यामध्ये किती व्होल्टेज सोर्स असू देत, किती रेजिस्टन्स असू देत, त्याच्या कुठल्याही 2 पॉइंट मध्ये एक व्होल्टेज सोर्स आणि एक रेजिस्टन्स आहे असं अज्यूम करता येतं. आणि जर ह्यात मोजताना ओपन सर्किट व्होल्टेज VOC असेल आणि शॉर्ट सर्किट करंट ISC असेल तर तो जो व्होल्टेज सोर्स आहे त्याचं व्होल्टेज असतं VOC आणि हा R जो आहे R तो किती असतो VOC अपॉन IS. VOC अपॉन IS. This is called as VTH and this is called as RTH. This is called as VTH and RTH. Right? So now using this solve the previous problem. So same problem, 10 volt 30 25 volt. We got a new sheet. So this is equivalent to what? So I is, what will be I? I is equal to VTH upon RTH plus A. Right? This circuit you write, prepare equivalent circuit whose voltage VTH, current is RTH, sorry, there is RTH, so current will be VTH upon RTH plus 8. So calculate VTH, which is open circuit voltage, and RTH is short circuit, open circuit voltage upon short circuit current. So open circuit voltage, very simple. When you open it, किती येईल ओपन सर्किट व्होल्टेज? 10 30 20 5 व्हॅल्यू सोप्या घेतल्या. सो 30 20 3 2 फरक पडणार. हे 10 आहे, हे किती येईल मग? कॉमन सेन्स किती कॅल्क्युलेट करता कामा नये. 10 वजा 5 भागिले 50 0.1 एम्पियर करंट 0.1 इंटू 3 30 3 वोल्ट ड्रॉप म्हणजे 7 राईट. VTH इज 7. इज इट ओके? बघितलं म्हणजे कळलं पाहिजे. 10 3 2 आणि 5 10 7 5 बरोबर. सो VTH इज 7 वोल्ट. नाउ what is RTH? 7 upon ISC. ISC कसं काढणार? हे शॉर्ट करायचं आणि हा करंट किती काढायचा? कसं काढणार? कॅल्क्युलेट दिस करंट बस. कॅल्क्युलेट दिस करंट. What is the answer? किती? Very difficult? किती? Calculate this current. हेच मी डायग्राम थोडी वेगळी करतो. सेम. आता येईल. किती येईल? Is it 7 by 12? Anybody calculated? प्रॉब्लेम काय आता? इतकं सोपं आहे. हे शॉर्ट आहे, इथं 0 व्होल्ट लक्षात येत नाही आपल्या. आता लगेच 10 - 0 आणि हे तिथं लक्ष, हे मुद्दाम थोडं तिथे वाटलं ती दोन्ही ऍड होते. तिथं ते अवघड एकदम कळत नाही. हे फक्त एवढं केलं कळायला पाहिजे. 10 by 30 is 1 by 3. This current 5 by 20 1 by 4. 1 by 3 plus 1 by 4 is 7 by 12. ISC is 7 by 12. So what is RTH? RTH 7 upon 7 by 12. That is 12. So RTH is 12. 12 ohm. So what is I? What is this current? 7 upon 12 plus 8. 7 by 20. That is 0.35. Is it right? So that calculating VTH is simple as open circuit voltage, but RTH, for that calculating short circuit current, and then again it takes some time. So there is another effective method. What is that? The RTH, that is equivalent resistance, can be calculated by short circuiting all the voltage sources. To be very classical, it is by replacing voltage sources by the internal impedances. But since we have assumed them to be ideal, short circuiting the voltage sources. So VTH is calculated open circuit voltage, and RTH, equivalent resistance, is short circuit voltage source. So short circuit voltage source, this becomes here. So 13 20 in parallel. 13 20 in parallel means 13 20 upon 30 plus 20. 600 by 50, that is 12. Is it right? So we just solve one more example using Thevenin's theorem, and I hope that this, they are not, it was not wrong, but some sequence you follow. Calculate I using Thevenin's theorem. पॉइंट ए अँड पॉइंट ज्यातला करंट काढायचा तो रेस म्हणजे त्या अलीकडे ए बी घ्यायचा तो रेसने काढून टाकायचा अँड प्रोसीड फर्दर. What is the answer? And you finished? What is the answer? No, not right answer. First, we should we should solve using Thevenin's theorem, right? What is V? What is open circuit voltage? You just remove this, right? So between A and B, what is V? What is the voltage at A? 20, 20, 20. So it is 10. What is voltage at B? 10, 10, 10. So 5. So 10 minus 5. Its voltage is 5 volts. What is RTH? Short this, short this. 20 parallel 20 is 10. 10 parallel 10 is 5. So you are looking between these two. So what it is? So I just draw 10 and 5. And it is 10 and 5 is 15, right? It is 15. And this is 5. So 5 upon 15 plus 5. That is 0.25 million. Is it right? 0.25 million. Is it okay? So I. Oh, sorry. 0.25. Is it right? So Thevenin's theorem is used by and large to make, it is not that in today's age it is not important. Only thing is that in today, since everything is now solved by using, you can have Google Lens, you can get the problem through Google Lens, you can give it to some application, you can get the answer. So for end user, there may not be any need to simplify because that answer you get. But for those who have written algorithms, for that this is important, so that it means you can remember Thevenin's theorem is not exclusive. Means if one doesn't know Thevenin's theorem, means prior to Thevenin, this theorem was not there. Still people used to calculate. Only thing is that this theorem makes the unnecessary, means just like when wheel was not there, still things used to move. Wheel simplified them. Like that Thevenin simplified the calculation. So Thevenin's theorem is still a basic building block in these circuits and networks, and it has got its own place, even though for solving problems you don't need to know anything now, because everything gets automatic for you. It is just like टेबल्स किंवा पाढे पाठ करायचे. पाढे पाठ का करायचे? कॅल्क्युलेशन फास्ट करता येईल म्हणून. मग पाढे ज्याला येत नव्हते त्याला कॅल्क्युलेशन करता यायची नाहीत का? यायची, पण त्याला फक्त ते पुन्हा आकडे घेऊन करायला लागायचं. मग आता कॅल्क्युलेटर आल्यामुळे पाढे पाठ करण्याची आवश्यकता नाही. That is a situation like Thevenin's theorem now, but it has got its own place, and while dealing with very complex systems, to find out the equivalent system, it is very much useful. So Thevenin's theorem, I think, means now today, say the significance of this theorem in the subject 50 years back and of today, there is a difference. So we don't spend much time on Thevenin's theorem. Otherwise, earlier Thevenin's theorem and star delta conversion of resistor. There are 3 points in which 3 resistors are connected in one manner and other manner. What is equivalent? That was used to be a very quite interesting thing. And there is one more which is again very simple. In GATE, you might have found these questions. If such junctions are there, all are R's, and they are connected at these points. At every junction is a connection. All are R's. What is effective resistance between a diagonal and is infinite network, right? It is infinite such square resistance mesh. What is resistance between its diagonals? Effective resistance A and B. Or if I connect a battery of 1 volt here, what will be I? Is the question clear? This was not there in recorded videos. Anybody? Now when we say, can I solve it using Thevenin's theorem? What should happen? By common sense it can be solved. Common sense. And the hint is symmetry. You take it out, elongate it and look it from third dimension there. Like this. So here and here. So its symmetry is there. Because of symmetry what will happen?
We can separate the nodes.
So what will happen?
So we can separate that junction where 4 resistors are meeting.
Then no.
We can easily
All are connected. You can't disconnect each and resolve by common sense, by symmetry. Infinite resistance mesh. So I think that instead of answering it quickly, let us give some scope to your curiosity. You continue to think and we discuss it in the tomorrow's lecture. I think it's enough.